All right, so there are we have done a few of these already, so this is just going to be some more practice. In order for us to remove discontinuities, we have to put in numbers that will allow either our limit from the left and the right to be the same, or in this particular case, just for our limit to match our f of value for this function. So this particular function is f of x equals, and then we have this equation that we use for everywhere except x equals -2. And then at just x equals -2, we have this value of k right here. Why is this not used at x equals -2? There is a hole in that graph, right? -2 would give you a 0 in the denominator here. So if we want to find the values that will make k fill in the hole in this graph, we just need to do the limit of this. And we're doing the limit from both directions because this is both sides. It's all the numbers less than -2 and all of the numbers greater than -2. It's everything except for -2, right? So for a problem like this, we would just do the limit as x approaches -2 of, I'm going to go ahead and put of f of x, and then I'm going to show that for this function, we would use x squared minus 4 over x plus 2. I'm going to go ahead and factor that numerator, x minus 2, x plus 2 over x plus 2, and those two values will cancel, and I can just plug in my -2. So -2 minus 2 will give us -4. Yes? You would probably be okay with either, like if you did not write this right here. I don't think it's a place they would count off for. You need to have one of these two, though, because this f of x is more than just this equation. In this case, it's only that one other point. It could be more important if you were doing like a left and the right there. I would write it for the left and the right to be really clear about what you're doing. All right, so what this is telling us is that if you plug in -2, you approach -4. So at -2, -4, you're going to have a hole in your graph right there. So we can very easily fix this here by just saying that k would equal -4. That's the value we need to have to fill in that hole. So this function, f of x, would be continuous because you have that hole, but it's being filled in by that point. So once we turn that k into a -4, it fills in the hole, so the function would be considered continuous. Now, if we were to talk about just x squared minus 4 over x plus 2, that has a hole in it, but the function altogether does not because it's been filled. Yeah. Okay. All right. Questions? All right. Okay. This is a similar one. I want you guys to try it on your own. you're good. So once something cancels, usually you should be able to plug in the number for your x, and you will get 0 over 0 anymore. So just go ahead and plug in that. Check with your neighbor and see if they remembered how to do it. They're also good because they make you review how to do some of those algebraic limits. Okay, you should get 1/8. So, oh wait, I didn't mean to do that.
I froze up at the easiest part. I didn't plug it in.
Yeah, Troy did that same thing. He got all the way to the end and didn't remember what to do. All right, so the ones with the square roots typically are going to be the ones where you need to multiply by the conjugate. Unless it's disguised, then it's actually a direct substitution. But if you try a direct substitution on this, you're going to get 0 over 0. So remember that conjugate is the square root of x plus 20 plus 4. We just changed that middle sign right there. So where it was a minus, we change it to a plus. And we're going to multiply on top and bottom. Okay? And then so when we distribute right here, we are doing square root of x plus 20 times square root of x plus 20. That gives us this x plus 20. We'll do the outside, and it'll give us positive 4 square root of x plus 20, but then we'll do the inside, which will give us negative 4 square root of x plus 20. Those cancel out, which is what we wanted to happen. That's why we chose the conjugate. And then negative 4 times positive 4 gives us a negative 16. And 20 minus 16 is going to give us 4. And then x plus 4 can cancel with the top and bottom. And you may want to, write in there that you've got, a 1 right there once you cancel out. You don't have to necessarily, but that 1 is still there on top. So I really should have parentheses if I write it like that. So the 1 remains on top. If you want to write another step with the x, you can, but at this point, once something cancels, you can plug in that value. So you plug in the negative 4. Negative 4 plus 20 is 16. Square root of 16 is 4. 4 plus 4 is 8, so you get 1/8 for that. These problems are really good because they also make you go back and review some of that other stuff that we did. Okay, questions there? All right, moving right along. I know this is fuzzy. Can't remember where I took it from, but it's fuzzy. These are hard to make up on my own, so I have to pull them from somewhere else. For what value of c is the function defined by this equation here continuous at x equals negative 1? Okay, so they're only asking us about x equals negative 1. Which means we can ignore part of this equation. Which part can we ignore? The last part, because this has to deal with 2, right? So we could check for continuity at 2 if it asks us to do that, but it's not asking us about that. So we're not even going to look at that bottom part of this function. Now, this is different than the first 2 that we did, because this time it's not like a function that we use everywhere except for this one piece. This time, we're looking at the limit from the left and the limit from the right. And for this to be continuous, Those two things have to equal each other, right? So, if we did, now on these, I would suggest doing the limit as x approaches negative 1 from the left, and I would say f of x first. That lets us know that you're looking at this whole piecewise function, and then from the left, we're looking at the equation, which is just negative x. So I'm using an f of x first, then I'm writing it again to show which piece it is that I'm using. I'm not sure how they would count that on grading. They might, if you left off that first part, they might be okay. I know I need that negative right there, though. But, you know, it would not hurt to write it like this. I would suggest writing it like this. Now, all I've got to do for this one is plug in that value. So negative 1 is going to give us 1. Okay, so the limit from the left as x approaches negative 1 is 1. Let's look at the limit from the right. Now, this is going to be a little bit different. So, limit as x approaches negative 1 from the right of f of x is going to equal the limit as x approaches negative 1 from the right of negative x squared plus x plus c. So, there's no like factoring on this one. There's no like multiplying by conjugates. This is a direct substitution problem. What do I plug the negative 1 in for? The x. Do I plug it in for the c? I do not, which means I'm still going to have a c in my answer. So I will have negative 1 squared plus negative 1 plus c. So when you're plugging this in, you're only plugging it in for the x's, not for the other variables that might be there. So when I do that, make sure you're doing your order of operations correctly. This would not be calculator active, so don't let this get you. What have you got to do first? Exponent. So negative 1 squared is positive 1, but that negative right there is still there. So it's negative 1 minus 1 plus c, which is going to give us negative 2 plus c. All right. What ideas do you have? It's not the answer because we need to know what number c needs to be.
Make that equal -1.
Okay. Are you sure about that? We are gonna have to make it equal to something. We gotta make this. What has to be true for our function to be continuous? Make it equal to what? Just regular 1. Why do we use the regular 1? It's the limit from the left. This was my limit from the left. This is my limit from the right, even though it's not exactly a number. Those two have to equal each other for these to be continuous, right? So, I need to quit saying right. Correct. There's potential to be confusing. So, our last step is just very straightforward. Negative 2 plus c is going to equal 1. We would add 2 to both sides to solve that. C would equal 3. That would be our answer. There. We okay there? All right, here's a calculator problem. Okay, now we're still going to write some of this out by hand, but we're going to need our calculator to get to our final answer on this because we're going to end up with something we don't know how to solve. So we're still going to write out our limit from the left and limit from the right. So in this case, it's telling us this function is continuous for all real numbers. We need to figure out what the values of a, which are right here and right here, need to be. Now, a is the same number in both of those places. So if A equals 2.713, it equals 2.713 for both of those. Now, e to the ax is always continuous. It's an exponential. They don't have any points of discontinuity, so there's no issue there. 2x plus a, what type of equation is that? Linear, linear, always continuous, right? We don't have any discontinuities within those sections, which means the only place it might be discontinuous is where? What x value could we possibly have a discontinuity for? It's going to be the place where these two pieces meet. Where do they meet? 3. X equals 3. Because we're using this one for x is less than or equal to 3, and this one for x is greater than 3. What we want to see, like right now we don't know because we got the a's, but we want to see those two, like where this one ends with a closed circle, the other one starts with an open circle. So, if we do the limit as x approaches 3 from the left of f of x, that would be the top function. Limit as x approaches 3 from the left of e to the ax, which means we are going to plug in 3 for the x, not the a, just the x. So that's e a times negative 3. We probably would rather write it like that, this e to the negative 3a, because I did it wrong. Let me fix that. I was looking at my negative behind. That means from the left. Don't do what I did. All right, positive 3. Thank you. All right, so this is, if we're kind of thinking about, it might not even be a bad idea. This is the limit. Oh, can't write with that. Never mind. It won't let me write for this. Let me use a pen. This is my limit from left. Okay, you may want to label it because you're getting something weird. Normally we get a number, right? But we're getting something weird here. We also need the limit from the right. So limit as x approaches 3 from the right of f of x is going to be the limit as x approaches 3 from the right of the bottom function, 2x plus a. And we're going to plug 3 in for our x coordinate. So that would be 2 times 3 plus a. That would be 6 plus a. So we're looking at here, this piece. This is our limit from the right. Okay, so at 3, limit from the left and limit from the right. Now what happens here is we get, these two need to equal each other. So we get e to the 3a equals 6 plus a. And if we had more time, I'd let you sit here and try to solve that one for a minute. I'll go ahead and tell you we don't know how to solve that one. And there's no, as far as I know, not a method for solving it by hand. Now, there may be things out there that I don't know about, but definitely not anything easy that we could do. So, that is why this is a calculator active problem. So, if we, wait, we don't want that calculator. Nope. Let's pull up our fancy new calculator here. All right, and so to do this, I want everybody follow along. Okay. I told you earlier you don't have to clear out these calculators, but if it just gets on your nerves that all that other stuff is there, F1 and 8 will clear off that home screen for you if it just bothers you. I'm gonna clear mine off so it's not, so you can follow what I'm doing a little bit better. So we need to solve an equation that is under algebra. You see those tabs up there at the top? They'll tell you what you're looking at. So F2, algebra, and then We want to solve, so we'll say solve. And then you can use an A for this if you want. I would just use an X because it's easier to type in. This has an alpha button. You can type in an A if you'd like. I'm just going to use an X because it's easier to type in. So I'm going to say e to the 3x equals 6 plus A. Oops, wrong thing. Yes, you're right. E to the 3x. So to get your E on this one, you can either do, there's an E somewhere. There's a, yeah, that's actually your E to the x, which is what we need anyway, so it's fine. There's a regular E, some way to get to it, I can't remember.
You just put E to the point.
It might just be the letter. But anyway, we're going to do E to the, what was it, 2A? 3A. 3x, I'm going to do an X instead. Make sure you close that parentheses. If you do not close that parentheses, it's still in the exponent. You have to have everything typed in correctly with your parentheses. There's an equal button right here below your X, so you'll hit that. And then 6 plus X. It cannot solve unless you tell it which variable it's solved for, or it's solving for. So you're going to have to put a comma, which is right above the 9, an X, and then close your parentheses. On these calculators, you want to check whenever you get it typed in. If you've got 1, 2 parentheses open, you have to have 1, 2 parentheses closed. If you have if you have a mismatched number of open and closed parentheses, then guarantee it's going to be wrong it's going to give you an error whenever you hit enter. So everybody got it typed in, okay? Comma's above the 9. Alright, so we're going to hit enter. It's going to warn us that more solutions may exist. It also warns us that we have questionable accuracy. It uses the estimation process on some types of problems. So it warns us that we have questionable accuracy. But we have some options here. We got -6, another -6. It's probably got a huge decimal with it. Is that why they... Does yours have a decimal? And mine does. And then we got 0.630563. Now, it would depend on the problem. Alright, so it warns you that it might not do this right. So, if I plug in -6 over here for the 6 plus x, what will I get? 6 plus -6. 0. I'll get 0, right? So I will get, I may have said it backwards, but 6 plus -6 is going to give you 0, right? What am I going to get if I plug in -6 on this side? I'll get e to the -18. Is e to the -18 a big number? It's actually a really, really small number because it's 1 over e to the 18th power, which is really small. So what happened there is the calculator thinks that those two things are equal because it's using an estimation process here. So it would be correct like within certain decimal places, but it wouldn't really be like the correct answer. The answer we really want to use is this decimal 0.630563. And on the AP exam, I had you guys do this in pre-calculus also. On the AP exam, you must be correct to 3 decimal places. Okay? So, just writing the whole number down, perfectly okay. You can do that. If I write down x equals 0.631, perfectly fine. If I do x equals 0.631274, I messed up somewhere, but they're still going to count that right because it is correct to 3 decimal places. They are going to look right here, and if you're correct to there, they're going to count it right. Now, I would either write this or this as my answer. I would not test them by throwing gibberish out there. And if you did like 631,721, they would not count that correct because that would round to 632. It would be off more than 1 decimal place, or more than, it would be off to that 3rd decimal place. And in some cases, depending on what it looks like, they will sometimes count if you just truncate the number, if you do this. I am going to count off if you do this because this is wrong. It does not round to 630. Sometimes on their rubrics, they let you get by with that if you just chop it off. Just because it is not a test in rounding, it's a test in calculus, and there's very little way you're going to get 0.630 incorrectly. You just were lazy on your rounding. So they will sometimes let that go by. I will not. I usually don't count off full credit for it. That's where you might get some of those half points or something that they don't give, but I will.
Would you have to write it as A instead of X?
You should, yeah. Yeah, you definitely. And it would matter on this too. It would matter on this because there is an X in the problem. So, yeah, that would get you there. So, we should write it as A. You can type it into the calculator with an A. Because if you just do alpha, like if I'm going to do that same thing, let me type it in real quick. Solve e to the 3a equals 6 plus a, comma, a. It can solve for other variables there. You just have to consistently use the a until you're solving for the a. We'll get the same answers. All right. Let's see what we did not get to. I'll skip and do this review question just because I really want to look at it. Example 5, you may run into one of these. You may have to do something a little different that you haven't seen lately in 5. Maybe not. Yeah. If you need to on homework, you can use the calculator. Let's look real quick at this. We want to know if g of f of x is continuous at x equals 1, and we have to justify our answer. So that means we would be doing the limit as, actually first we would do g of f of 1. Let's do that first. Okay? This is f, this one is g. Oh, never mind, this is not a hard problem. But I do want it to be, did I want it to be g of f of 1? I did. We'll look at it tomorrow because I don't want to mess it up